Hi, everybody. Okay, now that we know the 6 movements to assess mobility and then the 6 movements to assess stability in the 3D MAPS system, I wanted to get Gary Gray to explain it to you a little bit on this video. And so, again, the whole idea behind 3D MAPS is that we can use this three-dimensional movement paradigm of the matrix to identify successful mobility and stability in our clients throughout the body by creating chain reactions. And the beauty of what we've learned through muscular slings, and then we called them anatomy chains, and then I showed you anatomy trains, is that we're thinking about the body in complex ways three-dimensionally. And so I wanted, in the next 6 minutes, for Gary just to kind of take one of the movements of the 3D maps and kind of talk you through what each joint is doing. I think this will be really helpful for all of us. So here's Gary.
Appreciating the chain reaction biomechanics of the frontal plane is just as critical as it is in the sagittal and in the transverse plane. In the frontal plane, we know we're going to create a motion with our foot with a lunge, and at the same time layer on a motion with our hands to facilitate all of that chain reaction motion. If you zero in on taking a look at my trunk and taking a look at my left hip, just by taking a look at my left hip, if I do a right foot, right lateral lunge, which means a same side lateral lunge, I'm taking a same side lateral lunge, what I have is I have the revealing of left hip abduction. As I come back, if I just put my hands over my head and I do a swing to the left side, all of a sudden, again, I'm showing left hip abduction. If the goal is to have the body reveal how much functional mobility it has in the left hip, in the frontal plane, into abduction, then we realize that we're going to lunge and we're going to swing our hands at the same time to where we can go as far as we can, and then, of course, come back home. We're going to get there and then come back home. Now, as we know in 3D maps, the mobility movement involves using this foot to help decelerate all of this motion, this chain reaction motion, primarily with the lunge leg and the entire core. But as we know, we'll then go to a toe touch, and then we'll go to a no toe touch, where now all of a sudden this same side lateral chain, as we call it, is going to need to reveal itself without the benefit of the lunge leg, and therefore we're going into what we call a stability movement. It's key to understand that the mobility movement and the stability movements are the same. The stability movements, obviously, because the body has to decelerate all that motion itself without the benefit of the lunge leg. The motions are the same, but in the stability, the motions are just a little bit less. However, still the same chain reaction biomechanics. Now, again, taking advantage of this, we ask ourselves, what are we going to do to take a look at that left hip abduction? We're going to do what we call a same side lateral lunge, and taking our hands to the opposite side. So this right foot's going to the right and the hands are going to the left, and we immediately see this chain reaction biomechanics of the left hip going through abduction. What's beautiful about this is the entire body has to react to the motion of the foot and the motion of the hands. And therefore, the chain reaction biomechanics, we can look at not only what the hip's doing, but what the knee and the ankle subtalar complexes are doing, but also what the spine is doing and what the shoulders are doing. Let's take a look at that. Let's go from the hip now. Let's go down to the left knee. As I, again, do my lunge, and I take my hands and I go the opposite way, not only my left hip is going through abduction, but my left knee now is going through abduction. This left knee kind of shows more of a valgusing, so to speak, or what we call abduction of the left knee. Critical thing to take a look at, not only with mobility and stability in all of human movement. As we go down a little further, we go from the hip now to the knee and take a look at the foot. Now the foot's going to show us a frontal plane motion. So when I come out here and I show you my 3D map same side lateral movement, all of a sudden we see what the subtalar joint and ankle complex of the left foot's doing, and we see that it's going through eversion. And that makes sense because as we get in that position and hold, we see the eversion of the foot, we see the abduction of the knee, and as we work our way up, we see the abduction of the hip. A chain reaction motion that is being facilitated by this leg going through a lunge and the hands going through a opposite side lateral overhead swing. Now, again, the beauty of 3D maps is it just doesn't stop there. It now facilitates what happens up into the spine. And many times to see a little more of the spine, it's almost easier to kind of look at me from the back. So if you don't mind, I'm just going to turn my back to you and go through that same motion. But again, if I go through that same motion with my hands here and I show you the chain reaction biomechanics, you can appreciate again what's happening here, but immediately you say, wait a minute, that lumbar spine is laterally flexing to the left, the thoracic spine is laterally flexing to the left, and if my hands follow the arc, if my eyes follow the arc of my hands, you'll see that the cervical spine will have lateral flexion to the left. And you'll say, wow, I think that's critical to see. We need to see what the spine does in the sagittal plane both ways. We certainly need to see what the spine does in the frontal plane both ways. And the frontal plane chain reaction, same side lateral as well as opposite side lateral movement in 3D maps will reveal that to us.
I'm going to skip ahead to where he summarizes what he's just done for us.
The eversion of the subtalar ankle complex. Again, we realize that 3D maps offers us a very effective and efficient way to appreciate how the body functions. The whole goal of an analysis system and the whole goal of a performance and rehabilitative system. Therefore, when we go same side lateral, our chain reaction biomechanics reveal to us the mobility, then ultimately the stability of the body going through hip abduction, knee abduction, subtalar ankle complex eversion, lateral flexion of the spine, especially if the eyes are going with it, cervical spine going the opposite way, that lunge side shoulder going into abduction, the opposite side shoulder going through adduction. A wonderful appreciation of a functional movement pattern that the body takes advantage of to do so much, and therefore giving us the opportunity to say, if you appreciate my chain reaction biomechanics and understand my ability of mobility and then my ability of stability, you'll have a great appreciation of my ability in the same side lateral chain reaction because of your understanding, your appreciation of biomechanics.
So you can see a pretty easy concept, but he goes joint by joint, and that's what I like and wanted to share with you. So we're going to have fun as we discuss each of these movements joint by joint in the future. Thanks for listening.